these are similar polynomials. So tell your group, talk to your group right now. What is the pattern that you see with these polynomials? All right, now some of you guys might know how to factor this really fast because you recognize the pattern. Now I want you guys to divide and conquer. I want those three polynomials factored at your tables. Go. Okay, if you weren't trusting of the person that knew the pattern at your table, maybe you attacked one of these, right? You took the first one right here and you said to yourself, all right, so if I do the big X thing, I'm going to go like this and put the 25 up top and put the 10 on the bottom. So what two numbers multiply to give me 25 add to give me 10, and you thought 5 and 5. Then you're like, oh snap, so it's x plus 5 and x plus 5. And then you're like, oh snap, I can write this a different way. I can write it x plus 5 squared. Oh snap. And that's the pattern. That's the pattern that I wanted you to recognize. Okay, so the first one would be x plus 5 squared. Do you guys know what the next one would be?
X plus 8 squared.
Ooh, x plus 8 squared. So you guys see it? Do you guys see the pattern?
Yeah.
X plus 8 squared. All right. And then what would the next one be? X plus 3. Okay, does your shortcut work for this guy?
No, it's x minus. X minus.
It says x minus?
X minus 6 squared.
All right. Factor it. Go. I'm going to pause and you guys factor. After factoring it, did you guys see it? Is it the same pattern?
Yeah.
Oh. Yes, it is. What's the only difference? It's a minus instead of a plus. So it's still considered a perfect square trinomial. That's what these are. They're perfect square trinomials. All right, now I'm going to mess with you a little bit and ask you, does your method for factoring work for this one? These guys right here.
That one's
all right, go. Think about this. See if you can get the answer really quick. So my first question is, do these guys right here follow the same patterns as these ones up here? They don't look like it, huh? And I think I know what you're thinking, because for this top one, you thought okay, 5 times 5 gives me 25 and 5 plus 5 gives me 10. Did you guys think that? No? You thought something different? Or you just didn't think?
I just didn't think.
Okay, so that works for all these actually. 8 times 8 is 64. 8 plus 8 is 16. 3 times 3 is 9. 3 plus 3 is 6. Okay, I don't know if you saw that. Now I'm saying 3 plus 3, or you can go 2 times 3. Right? What's the square root of this one? It's 6, and then 2 times 6 is 12, but this one has a minus. So, but I don't know. The pattern stuff. Okay, that doesn't quite work over here, because the square root of 4 is 2. 2 times 2 is not 12. Now, because the first term does not have a 1 as the leading coefficient, these ones are slightly different. Now, we could do the long way of factoring this. We could just factor this like normal without recognizing the pattern. But patterns are nice because they're like shortcuts. And so you want to know the shortcuts, don't you? Okay, so let's see. If I was to try to factor this the long way, what I need to do is, actually I don't want to do that one. I want to do the other one. So 4x squared. Okay, so what you do is you go first term times the last term, which is 100. And then on the bottom we have 20. Okay, so what multiplies? You guys know how I got the 100? 4 times 25. And then 20 goes on the bottom. What times what gives me 100 but adds to give me 20?
10.
Oh, hey, it's 10 and 10. That sounds simple, right? So then I go plus 10x plus 10x. And what is 10x plus 10x? Oh, yeah, we already did that. It's the 20x. So I just split up the middle term. There he is. And then on the end I put plus 25. And then I do my grouping business. Or you like the tabular method, you can do the tabular method. Okay, what can I take out of the first two terms? These ones. 2x. So I take out 2x, and what do I get? I get 2x plus 5. And what can I take out of these two right there? I can take a 5 out, so I go plus 5, and oh my snappity whack, we have 10 divided by 5, which is 2x, and then 25 divided by 5, which is 5. So I got to go plus 5. And then I take out a 2x plus 5, 2x plus 5, so I get 2x plus 5. And then, oh look, there's a 2x plus 5 again. Oh my gosh! So I can write it out like that, or I could have done the shortcut. You guys like shortcuts, don't you? 2x plus 5. Oh, shoot. So my answer is actually just 2x plus 5 squared. Wait a second. Isn't there like it's like the same as these ones. But it's slightly different, huh? Okay, let's talk through this really fast. How did I get 2x?
The 4.
Square root of 4x squared. How did I get 5? Square root of 25. Okay, now check this out. What is 2 times 5 times 2? Right, what's 2 times 5? 10. Times 2? Oh. Does that work right here for this one? Square root of 9? Square root of 4?
2.
What is 3 times 2
6.
times 2?
12.
Oh. It's like the middle one is always times 2. What? Okay, so now I'm going to stretch you guys even more. Okay, now if you haven't figured it out, all the patterns on this page are the same. So here's another one. Can you guys shout out what the answer is right away?
5 times 5. 5.
You got it. Okay, we're going to... Actually, I'm going to write it out, and then I'm going to delete it, because this one's actually in the way. So, 5x plus 5, and then you square it. Okay, and what about this guy? Oh, snap. This guy, things get weird. We got 2 variables. So, in a second, I'm going to give you guys some formulas, but really quick, for those of you guys who got this one, let me tell you the answer. You get... No, you don't get a cookie. Okay. You know it's something squared, right? It's 4x, because that's what I get when I square root that. And then if I square root that, what do I get? 2y. So 2y. Now, is it plus or minus in the middle?
Plus.
I know it's plus, and you know it's plus, because this says plus. If it said minus like this, then you know the minus would be in the middle. So I'm going to put a plus right here. But now, does this work out? Do you actually get 16xy in the middle?
Yes.
What is 4x times 2y?
8xy.
8xy times 2?
16.
Hey, so it does work. Now, maybe that's still confusing to you. Is this still confusing to you?
No. Well, yeah, but when do you want me to take the break?
In the brunch. Okay, so, no, not end. Okay, so, do you guys know, actually, okay, now we're gonna do some general things so you guys can see some patterns, okay? Let's do an easy one first. These are the main patterns that you guys got to recognize for this next section of your learning. Can you guys multiply? Actually, we'll use the same letters as con. We'll go u plus v times u plus v. Can you guys, not u plus, dang it, minus v. Can you guys write out what you get when you multiply those together? So if you multiply it out, now if you know the shortcut, then you went straight to the answer. But I'm going to multiply it out so you guys can see how I get there. U times u, what do you get? It is u squared. What is u times negative v? Negative uv. And then we have v times u. What is that? It's also uv. So we go plus uv, but it's not negative, it's positive. And then we have positive v times negative v. Negative v squared. Oh, snappity whack. We have negative 1 uv and positive 1 uv. What happens to those? They cancel out. They die. Everybody say, "Aw." So here's the money shot right here. You see that right there? That guy and this guy. So if you see a difference of 2 perfect squares, you can factor it like this. That's the pattern. And you guys already know this one. That's why I did it first. So like if you guys had 25x squared minus 16y squared, because this is a perfect square and this is a perfect square and it's a difference, you know the pattern. You can easily factor this without actually doing all the factoring stuff. Right? Everybody cool? All right, so now write this one out and multiply it. U plus v squared. Simplify it. So here's the mistake that a lot of you fools make. Now, some of you guys are this guy. Only some of you guys. Okay? Don't be this guy. Okay? Look at this guy. He's a plus b squared. That's this right here. And this a plus b squared is supposed to be, this guy, this girl right here. But a plus b squared is stupid, and he's looking at the a squared plus b squared. So if you wrote a squared plus b squared on you are this guy right now. Don't be that guy. Don't be that guy. So this is how you do it. You go, this is the same as u plus v times u plus v. Guys, that's what the 2 means. Okay, now, what is u times u? U squared. U2. What's u times v? uv. What is v times u? uv. And then what is v times v? Okay, and now you have 2 uv's, right? So you get u squared plus 2 uv's plus v squared. Do you guys remember the 2 that kept popping up?
Yeah.
Like we would multiply the 1 and the 6 by 2 to get 12. We would multiply the 3 and the 2 by 2 to get 12. That's what that 2 is. See the u and v? You multiply the u and the v together. What's the square root of u squared? And what's the square root of v squared? So you have u times v times 2. Look, that's the middle one. It's like a freaking formula. I'm sorry, I got a little excited there. All right, because this video is getting way too long, I'm going to just tell you guys what this one is. It is u squared minus 2 uv plus v squared. Now, why is this plus? It says negative right here. Well, what's a negative times a negative? So you guys, this is what you have to recognize. You have to recognize these 3 right here. When you see these guys, do you know you can factor it into these guys? That's the pattern recognition that you must know.